the majority, 45%, was coming from controls. So really the BMS or the EMS overcharging, deep discharging, so kind of causing glitches in the system. I mean, it sounds trivial, but if you're charging so many cells at the same time, slight coding errors can mean that the one cell at the end is just being overcharged. So that was 45%. And then 40%, or a bit more like 43%, was related to the balance of system. It's just electrical fires, an HVAC system failing. So, but identifying that and identifying there's a heat spot in the system, like there's a temperature anomaly that's coming up, identifying that and tying it back, the HVAC system is failing. In due course, this can cause a fire. Now, looking at imbalances, now this is tied to that potentially, right? So you can have like thermal imbalances, meaning that battery cells are charging and discharging differently, so causing imbalances in the system that are stronger than needed. Now, you can obviously go back and increase the amount of balancing you want to do, but maybe you also want to revisit the cooling system. Now, if you do that and you ramp up the power of the cooling system, your round trip efficiency might suffer from that. So you kind of see that causality that exists on the battery storage and why it's so important to understand how they all tie together, but also to get a holistic picture. And the risk, I think, if you are just focusing on that one red light that comes up, then you might miss the bigger picture of what else has been happening and how can I go one step further and solve a systematic issue that I might see on the storage instead of just solving that one kind of mini symptom. I think you would, if you were a doctor, you're treating the symptoms or the actual disease, and to really look into that. And I think that's a big issue there.
Through that too, you did mention, so like you believe the safest systems often end up being the most profitable ones. I think that's a powerful point. Why do you believe that? Like, tell us a little bit about that.
I mean, so I think the safest systems usually should be the most performing ones as well. But the interesting part is that if you're proactively managing your storage and you proactively replace components that are dragging the performance down, these are usually also components that in due time might cause a safety risk. So the more you see components on the system failing, the more likely it is that something goes wrong on the controls or something goes wrong on the cell side as well. Or you get like just occurrence that you don't want to have in the battery and then ultimately causing these causes for failure of the batteries. Is this, do you just react to something happening? And that might be potentially catastrophic, or do you generally use predictive maintenance, preventive maintenance to ensure that none of the components ever cause an issue? And if you do that, that usually also translates to very, very high performance availability and therefore high revenues.